The Wipeout course begins with a slippery ramp. Say the contestant has a mass of 70 kilograms and stands at the top of the ramp, which has a height of 10 meters and an incline of 45 degrees. The coefficient of friction is 0.03. We can find the weight by multiplying the mass by g. So how long will it take for the contestant to get to the bottom of the ramp? First, let's draw a free body diagram. Using geometry, we can find the length of the ramp equals 14 meters, and we can also find the components of gravity. The perpendicular component of gravity is equal to the normal force. We can use the equation, the friction force equals mu times normal force, to find the friction force, and then we can subtract this force from the parallel force of gravity to find the net force, which is 470 newtons.
Using Newton's second law, we can find the acceleration of the contestant, which is 6.72 meters per second squared. Then, using our kinematics equations, we can solve for t, and find that it only takes him 2.04 seconds to get down the 14-meter ramp.
Wow, that's really fast. He's flying. On the dizzy dummy, contestants are spun around to make them disoriented.
It's also a great example of circular motion.
The dizzy dummy has a radius of 1.5 meters and a period of 5 seconds. How big is the centripetal acceleration of the dizzy dummy? We can use the equation v equals 2 pi r over t to find that the velocity is 1.89 meter per second. Then we can use the equation acceleration equals velocity squared over radius to find that the acceleration of the dizzy dummy is 0.714 meters per second squared. Welcome to the Wipeout Zone, where contestants are catapulted into the water.
But how far are they catapulted?
He's a projectile once he leaves the catapult.
We know the initial height and that the initial speed is 15 meters per second. We need to find the horizontal and vertical components of velocity. Using an equation for vertical projectiles, we can find that the time it takes for the contestant to have a height of 0 meters or hit the water is 2.259 seconds. Now we can use that time in our horizontal projectile equation and find that the contestant splashes into the water 33.89 meters from the catapult.
Ouch.